So a deterministic systems with the stochastic inputs, and we said if there is randomness or so on in the system, we consider it as an additional input. So in this example, the output is a random process, which is a function of the input. So the output is a random process and input is another random process. So if we specify the output of your experiment as a C, this becomes a deterministic signal, this becomes also a deterministic signal, and everything else is deterministic. So if you define these on a probability space, L, your sigma algebra and a probability measure, so as soon as everything is determined, what member of C inside L happens, then everything is determined. So the description and the relationship between input and output is a deterministic relationship. And then you have a time signal at the input, a time signal at the output, and the system can be described. And then this is analysis of just deterministic systems. Now, we define a system to be memoryless if the relationship between input and output is such that the output at any given time t is only at a function is only a function of the input at that particular time. So this is a definition that you knew from your undergraduate course. For example, if you say a system is memoryless, mean of y of t, this random variable at time t is only a function of x at time t. So this is just a function of that. So you calculate this one. And obviously, so this function is not a time. So this is a value that y can take. This is the value that y can take, and you can calculate. Obviously, the distribution may be a function of time, or this function itself could be a function of time. Similarly, if you want to calculate the cross correlation between these two, so you could write it like that. So you calculate this is the value that y takes at this time and the value that this k takes at this time. So this is going to be equal to integral, because you have two random variables, so you have to integral it over let's say x1 and let's say over x2. This is from minus infinity to plus infinity. This is from minus infinity to plus infinity. So then you have x2, and then you have t of x1, and then f of x1 and x2 of x1 and x2 at time t1 and t2, dx1, dx2, etc. So you can write all the moments of those systems. So the nth order joint PDF samples of the input and output also can be calculated.